Oh, this is trippy. Check this out. This is just from macOS.
The fuck is that?
This thing has a mic and camera built in, and it has pretty good software, and it does tracking, and it's tracking me right now with varying success. It's in the new OS, which is in developer beta, which I installed, which mixed feelings about. This is an interesting feature. Trippy, but yeah. Also, this is exactly the kind of question asked Perplexity, which already makes it useful. Like, get me set up with Lean 4 and just say you have macOS or something.
What's its cutoff date?
Is constantly searching new stuff, so
Oh,
that's not a
that's
problem.
fine.
That's why it's supposed to be like the alternative to Google. Like, have you ever used it?
Perplexity? Yeah.
Yes. Well, good. You'll find out then. The Pro lets you use more models, in particular, being able to use the new Claude, which is really good, especially for code.
Is Claude better than GPT or
For
GPT?
code, the newest GPT is not even as good as the old one, but in a specific way, where it's faster, more than twice faster, and it has been trained on more modalities. So its ability there is unprecedented.
But it's worse code wise.
Yeah,
Okay,
and text wise.
that's good to know.
Likely whatever they come out with after will be better in all regards. The new Claude is just pretty smart. And like I gave it some question about push forwards and pullbacks. And although it couldn't answer it, it could tell that some response being given to it was wrong, just on basically intuitive grounds.
Hmm. Is it about level of like what second year math student?
This one would be far above a second year. Like, a,
I think most, at least at Caltech, we did push
like
forwards and pullbacks in first year.
okay, like a second year, what level? Like top university level, then sure. But that's I don't know why people have this thing of shifting the bar from like average-ish human to like the top humans, which is a bar that people are told not to do in their own lives, or like don't compare yourself to others or something.
But that's bullcrap. You're supposed to compare yourself to others. It's the only way we ever get things done. I think the only thing that ever motivated me was comparing myself to other people. I have zero intrinsic motivation.
That's really depressing.
I know. Dude, believe me, I wish it were false.
Like, why did you do math? Because of your like life circumstances? Do you like
Because I'm
math
good
itself?
at it.
Okay, well, obviously you know that there's plenty of areas of math that are real hard that you would not be nearly so good at.
Yes.
Have you engaged with any of them?
No.
Is it because of this fact?
It's because the people in them I didn't respect.
Oh.
The thing that motivates me is wanting to like be competitive with people I respect.
Do you respect your dad?
Yes.
Your mom?
He's too far up now.
He's too far up to what, deny otherwise or something?
He's too far up to ever reach. There's no point competing with my father. He's just too good.
Okay, well then use that feeling like an AI. Although this is basically how he feels about AI as far as I can tell.
My father?
Yeah.
Mm, not the current one. His current bed.
Yeah.
He thinks he will be, what's the word? No longer useful, not competitive with AI, like as a mathematician in about 5 to 10 years. He doesn't really have any good reasoning for it. That's just,
That seems fine. Okay, but like even 10 years is not that long. Odds are like a lot of mathematicians he'll live quite a while, which is nice.
yeah.
Like
He'll probably be retired by then anyway, so who cares?
Actually, your dad is a good example of like the recursively weird thing where I remember even just like walking up the stairs with him where he did all 9 floors of Evans Hall apparently every day and doesn't bother the elevator just cause, as far as I can tell. I don't think it was like that deeply considered.
It's because no, it's fairly deeply considered. He doesn't like take the car because he wants to do exercise. He thinks he'll be much fitter if he just like never uses.
Okay, well, this is points and evidence of him living longer.
Oh yes, he's quite by far the fittest. He's probably the fittest person I know. Point blank, forget his age. Like he
Wow.
runs marathons.
Okay, I didn't even know that. See, that's like a good indication of someone interesting when they've done some major kind of achievement that you didn't hear a word about, except in passing.
Yeah,
Then they're
quite
interesting.
quite cracked.
Well, you can at least feel similarly about AI. A
Hey,
What's up?
long time.
long time.
You guys know each other?
Yeah.
From where? Oh, Redwood. I see.
I like your new hair.
Your hair's changed. I don't think I even noticed that.
I mostly just got lazy about cutting it.
Huh.
You used to have really short hair, yes?
Yeah,
I do not. I do remember this actually.
having short hair.
How do you guys know
Not the
each
part
other?
where I shaved my head bald.
Friend of my ex.
Oh. As in, he's a friend of your ex?
Yes,
Yeah.
more than she is anyway.
I should,
Theo is very down on AI.
Oh, wait, sorry. Did I misgender you?
yeah.
What?
Oh, you said more than she is. Okay, okay, okay.
More than she is a fan of
Sorry,
her
sorry,
ex.
sorry.
No, I'm just a dude.
Okay.
Is he still doing the quant stuff?
Yeah. So are you, it seems.
Oh, that's. I think I've gotten very, very bored.
Of being a quant.
What?
Of being a quant or just in general.
Being a quant, yeah.
But you haven't even started.
I know. That's the worst part. I
Speaking of
just.
starting, show me your screen.
Yeah. What are you up to?
Why are you on the AI winter?
I don't know what I'm up to.
I just picked random shit.
I'm up to, I don't know.
Are you doing anything this summer?
What do you mean? Am I doing anything? I am technically doing something.
Every time I talk to you, you're like, I don't know what I'm doing. Blah, blah, blah. And then you're like, oh, I gotta do work. And then you tell me that you've been doing nothing. How's your
Yeah,
project
pretty
going?
much sums it up. I mean, I spent like this week I spent one day on my project. Like the equivalent of one day, like 8 hours. And my advisor was like, wow, this is so cool.
Have you ever read this book, Daily Rituals? It might make you feel better at least.
Dude, what's that?
Where it's like 200 or so 1 or 2 page descriptions of some person you have heard of, like Beethoven, Schopenhauer, various creative types, and their daily routine. And a pretty common theme is, yeah, a lot of people you have heard of. This doesn't work so well if you're a businessman, but at least for creative type work, including research, if you can do like even just 2 hours, but literally like every day,
Uh-huh.
but apparently this is enough. Also, you can totally be addicted to drugs and be successful, but they should be uppers. Because
That's
holy shit, do people do so much
that's
drugs.
that's pretty sad because I'm not addicted to any drugs and yet I still keep
Not even the
doing
good
it.
stuff.
Well, maybe it would help.
Maybe I should start doing some drugs.
Apparently, that's how Citadel is so
Like
productive.
shrooms.
Shrooms. I don't think shrooms are very good for productivity. I think it's cocaine that you want to go for. Not
No,
that I
no.
recommend cocaine.
I
Not
think it
that
would
I've
have
tried
way
it.
more negative side effects though.
Also,
Cocaine.
cocaine would feel like something for like 20 minutes, good or bad. It just seems like a bad spiral there.
Yeah.
Yeah. No, I've been told by
Like you
many
have to do a
people
drug
never.
3 times in an hour to feel its effects too much.
Really?
Well, if it lasts like 20 minutes and you want to be high the whole hour.
Oh, okay.
For cocaine?
Really anything, but yeah, cocaine in this case.
Really? I
Wait,
feel like
how much? So that's like so not worth it
Install
for
lean.
1 hour of like super productivity. Like, what? How much can you actually get done in 1 hour? Probably like 3x as much.
Well, given
or
that
something.
people only work like 1 or 2 hours a day, probably quite a lot.
Yeah.
Also, I have installed Learn. I'm trying to figure out how to.
Add it to your path.
Oh God, yeah, I'll do that. I'll do that. But yeah, oh, that reminds me, modafinil. How do I get modafinil?
I think you can just order it online. Buy
Is that a different drug?
It's a Bay Area. It's like caffeine, but better.
You
And
don't.
not
You never
as
heard of?
Oh wait. Is that the thing that people do like nootropics with?
I just went to this random sketchy-ish looking website. But if you really want one, I've got some. Not on me, but at my house.
Please, I don't want to put my favorite.
Wait, do people do like self-blind trials with that?
Yeah, this is part of what made Gwern famous in the first place.
Yes, I remember. He's the only person I've ever found who's done stuff like that.
I've considered. I found his website design because it's all in Haskell and it's online, and I was tempted to port it to Lean, but it would just not be like worth. Maybe just like copying it because I can read Haskell. Because his website has recursive pop-ups and stuff, which are definitely excessive, but I do like it. It's got good design too, just side notes
Do
instead of
websites.
footnotes. You can do static site and easily, and a site is static. It's based on Hackle, which is like Jekyll.
They're having a conversation there. Did you see about how to like talk to people at parties?
No, I wish I went to more of these lightings. I think it's too
Well,
late.
no, it's over now.
It's too.
But
No,
it was like extremely autistic.
really, you don't say that. The fact that this talk exists at all.
No.
There's like how to talk to girls at parties, which is like normal-ish.
Uh-huh.
But then there's like how to talk to
Yeah,
people at
yeah.
parties, which is not
Like
normal.
demonstrating how to like walk up to someone and introduce yourself.
This is very necessary
Yeah.
from my experience, actually. I
Like-
came here once and like no
I
one
think the
would
most
talk
important
to
thing
me.
for parties here is to just turn the lights off.
What do you mean?
Why?
That like it's 3 a.m.
Uh-huh.
People are somehow all awake. People are partying and talking very avidly, but the lights are like so aggressively on.
Oh, okay.
And it's since they're those powerful, what they call them, illuminators with a powerful white absolute brightness.
Yeah.
At 3 a.m. is just like being in Vegas. You can't tell what time it is. And it's not like a good effect at like 9 p.m. when the party starts, where it's just as bright and looks exactly the same, no matter how
Yeah,
dark.
maybe you should make that suggestion to them.
Sometimes I will just turn off one of the lights, and from the way people react, it's like a forbidden thrill where people usually are happy. But I think if I killed all of them, someone would turn one on.
Yeah.
Because there are people who just want to have a conversation, but like in the middle of a dance floor. And I'm all for that, but they should have to dance too.
Oh,
I
you
think.
mean like inside?
Yeah, yeah.
Wait,
Oh,
they
okay.
have dancing here?
Oh yeah, quite a lot.
They
What?
have like
I have danced here
little
so many
area.
times. I've
But-
danced there where all the chairs are right now. They'll clear it away.
Wait, when?
Over there, outside, over
Do
there,
you dance?
Yes,
a little bit
I
over
love
here,
dancing. I miss dancing.
over there. Literally, like every direction I'm pointing it, I've danced in, and I've not even gone especially for dancing. Although I have been here a lot.
When does this happen?
Also, these are all from different events. That one was something put on by Ayla at Manifold Markets Conference, which was a few weeks, month ago. Then over there, also one by Ayla, but also just by like other people separate times. So that one is not really specific to her. Here, mm, I think it's less online.
So
And there, Ricky Heiklin put something on. And over there, we did a mini one when I attended Jewish Shabbat at Manifest.
does not surprise me that you should here.
What?
Well, if you're going to learn about one religion in this community, it's going to be Judaism, obviously.
Why?
What do you think? It's because they're smart,
It's Jewish.
obviously.
I remember at
Like, have you seen the Midwit meme?
No.
Oh, oh man.
This was a thing at proof school too. I think I was the only non-Asian, non-Jewish person there in the entire school.
Okay, here. This is one example of it. This whole meme format.
I've seen this meme format, yeah.
Yeah.
Okay.
In this case, the take would be them Jews are smart. No, it's a complicated set of factors. Like, Jews are smart.
Okay. Where does that even come from?
Um,
It
Or
might be a
the
recent-ish
internet.
thing because, as far as I can tell, like the ancient Israelites were not like especially more or less intelligent than anyone in particular. They certainly did not have this reputation,
Okay.
and it's only associated with like Ashkenazi Jews, especially.
The theory that I heard was something cannot work on farms, starve to death unless you become a banker. I don't know. Seems a bit too.
Yeah, that explains like the money,
A just so
but not
story.
the.
Well, you need to be smart to make money, right? As
I feel like that's not true.
supposedly.
That's
I'm
what
thinking of the
rich
first
people.
quant who was also the first person known to have proved a theorem at all. Thales of
That
Miletus.
was yes, I remember.
Yeah. He was just
That
asked
was
if you're so smart, why aren't you rich? Probably not in those exact words, but that exact
Uh-huh.
idea.
No,
And so
someone
he took
else
it as
said
a
it to
challenge.
him.
Oh,
Yeah,
okay.
yeah. He didn't say it to himself.
And then
Certainly
he
not.
invented the first future. That's why Jump is so obsessed with them because they have a thing for like futures. And like, oh my god, blah, 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 or something.
Yeah, depending on the details of this, at what actually happened, either the first options or futures contract, but still, first quant also the first known mathematician. Although there's certainly people known before him. Like the Pythagorean theorem was already well known more than 1,000 years before.
No, they definitely gave this as an example of like the first future guys. Oh my god.
Wait, what time is it?
112.
Okay.
He was also the first person known to give an explanation for why things are the way they are that didn't appeal to like gods or religion, etc.
What was his explanation?
He eventually concluded like the essence of everything is water, which is wrong unless you interpret wave mechanics far more broadly than he would have probably guessed, which would be incredibly based though if true. That if actually he was thinking about waves in like this abstract mathematical sense and was convinced it's that. That would actually not be so far off.
That's
Although it's not
actually
like he had Poisson's equation or anything.
yeah.
I don't know what you're talking about.
He didn't have the Schrodinger equation, but he might
I
well
don't
have
know what
suspected
any of these things are.
wavy things used to describe mechanics.
Okay,
Or, you know,
cool.
the system of the world, how things work.
I see.
Emphasis on the how.
Right?
That was one of the more fun events over there. Listening to the debate about the two cultures and then ragging on Agnes for it. The two cultures is like the sciences and the humanities. And there's this huge gaping asymmetry where,
One is obviously correct then.
well, more simpler than even that, where one side can do the other, but the other side can't do the other.
Wait,
Like there's plenty of science people who are artsy. This place is a good testament to it. But there are very, very few people in the arts who are especially sciencey, and often examples that are held up, like what's his name? Brian May of Queen was someone who did learn drumming throughout his life and
Richard
was
Feynman.
played the
Oh,
bongo drums.
other way around.
Yeah.
wait, but people who can do both arts and science.
They tend to be like in the sciences though, if you look at like their life story, that you
Oh,
would say like they're a scientist, they're a
I see.
mathematician.
I see.
And in the case of Brian May, he was like obviously a physicist until he like went off and became the drummer for Queen. And yet he still went back to finish his degree, albeit as like an old man for honorary reasons. So that's not even a counterexample fully.
Wait, the drummer for
But I think
Queen
this
was a
shouldn't be like that
physicist?
controversial. Like the number of mathematicians who can do music versus the number of people who are primarily musicians who are, have discovered like anything in math. Like One Direction, I cannot think of even one person. And like you like unless you're just taking it in like incredibly bad faith, I think you like recognize this.
I think it's because it's
Yeah,
much
yeah.
harder to like get
Super
good at math
correct.
that you
It's
start.
because math is hard. That's
Yeah,
another midwit take
yeah.
of no, it's like teaching and
But
stuff.
also
But like
you're
sure, but
famous
it's
in your
hard.
20s or 30s, whereas you can do music anytime.
I'm thinking of Olga Holtz, one of the professors at Berkeley, my old linear algebra professor, who also plays with the Berlin Philharmonic.
Oh wow,
And yeah,
That's
that's some
crazy.
shit.
that's
Yeah.
impressive.
And has some work in, as far as I can tell, functional analysis.
How does she go to Berlin? Does she go to
Uh,
Berlin?
I think they travel a lot.
by plane, probably. I don't know. What do you want me to say? I don't know the sense that they're asking. Like, I don't know. Maybe show auditions or something. I have no idea.
Yeah, but how do you don't you have to like go to rehearsals every day or something?
She's not a regular member, as far as I know. That said, playing with them at all is quite something, especially when you're doing literally anything else,
Yeah,
especially something as being a
right.
mathematician,
Yeah.
which is definitely like the hardest job that a lazy person can still do.
Being a mathematician?
Yeah, and
Oh,
that
yeah.
you can do it drip by drip, but it will take up all of your attention throughout your life, inevitably.
I don't know about that. I think my dad does like 1 hour, like every 2 days.
Okay, but if you added up the moments in idle
Sure.
thoughts, your dad is thinking about math, and the amount of his subconscious devoted to it,
That's
it
true.
would easily dwarf like all his thoughts about you, and you like know this obviously. Or about any
That's
person,
crazy.
including himself.
That's true. It's hurtful to say.
But the thing is that it's true of like his wife, his family, his parents, his brothers, his self.
Yeah,
So
I
who's
know, I
left?
know. I see him like we have dinner and he just pulls out his book and starts reading. I
Okay, that's pretty autistic. Like a math book or just like a book?
He is like a math book.
Okay.
He is autistic.
Well, yeah.
Extremely so.
Yeah, he was my old algebra
The
professor,
second
so I
most
know.
autistic
Oh, really?
person I know.
Richard Orchards.
What? Oh,
Well,
yeah,
not
yeah, yeah. Her
mathematician.
dad, yeah.
Yeah.
Yeah, he's a professor at Berkeley.
Actually, even from supersymmetry yesterday, I was thinking, I don't understand how, but and I don't think he does fully either. His work is somehow ended up a bit in supersymmetric string theory, some of the group theory stuff.
Yeah, he said he used to do string theory. He said the only useful thing it did was do my tuition.
What?
He's very down on string theory.
Is it because it's so mathematically elegant and not much else?
Yeah. He says experimentally there just isn't anything there. Unfortunately.
I like that he does have a thing for concrete actual objects, which has certainly helped his like YouTube career.
Oh yeah, he's very much on the like abstract is dumb side of math. Well, not abstract is dumb, but he's
It
like
has to
you
prove
have to do
itself.
explicit computations like to understand something. He's probably the least abstract math guy that I know actually.
There's definitely some people I've met that are so much along this axis that I wonder.
Yeah.
Especially the entire category of geometers that seem to think without any pictures at all, purely algebraically. Jenny Harrison is like this by her own attestament.
Geometers?
Yes.
What do they think in terms of then?
Well, most geometers do think in terms of pictures like you would expect, but most probably think in some combination, of course, like anyone with training. Some who are really highly along the pictures only intuitive axis. Riemann, uh, Levschetz, and like at least one others. But there's multiple geometers, and I've only ever heard the set of famous geometers that they never gave a correct proof, but they never gave a false statement.
I can do that too.
Like Levschetz, they said that Solomon Levschetz was a purely intuitive mathematician. And he did good work in algebraic topology, so he's doing fine. Algebra is not like this. In particular, there seems to be like an entire category of mathematician that is, well, yeah, categorical. Like layers and layers of infinity category theory to describe like the different nuances of, well, shapes, like the ways they can be pointy and curved and stuff in various infinitesimal neighborhoods and stuff.
I think
Singularities, that sort of thing.
it's very niche. My understanding.
Category theory will take over math more and more. It
You
already
think
has.
that because you're obsessed with category.
I don't even use it in anything of my day to day for
Who
math.
uses it in day to day?
But I'm saying even restricted to math.
Okay, sure.
Like category theory, I use it mostly as an organizing tool in my head. It's especially handy for untangling various annoying sort of philosophical conversations where people literally get turned around on certain statements because they don't know the difference between covariant and contravariant.
I don't know the term.
I don't know what this.
Okay, here's an example. You can define more functions on smaller spaces than on larger spaces. Like consider defining a function on like a line. Then on the line it would have to be flat, but off the tails it could do whatever. But if it say it only had to be zero at a single point, then you have very little restriction at all, and you can define all sorts of functions.
Sure.
And in this way, the smaller the space, the bigger the dual space or the set of functions on it. That's contravariant because covariant would be like if it's smaller, then the functions would be smaller, or the functions are smaller, then it's smaller. But these two things wouldn't get flipped.
Okay.
But they retain the same like directionality, which becomes more clear when you start writing out arrows. Like in category theory, it really does just correspond to flipping things around.
This is a technical term.
Contravariant, yes.
Okay.
Yeah, that's something to do with dwarfisms.
Like in group theory, the classic example would be the opposite functor, which takes a group and maps it to the opposite group, which has the same elements, but you just multiply on the right instead of the left,
Oh,
or the left instead of the right.
I see. I see.
Which, as you can say, is a group and is basically the same as the original group. But this construction will always work. Functors are very important, especially philosophically, because if given some abstract thing, you can always get some other abstract thing. It's not always sensible to say that the smaller thing is like more fundamental. The exterior algebra would be an example of this. That you have the vector space, and out of it you can build multi-vectors, like the bivectors of planes, trivectors of volumes.
What's a trivector?
Alright, I have
Three
to go.
vectors range.
Good seeing you.
Say
I actually
that.
have to go.
Yeah.
Well, I work out of here, so I'll probably see you anyway.
Okay.
I'm gonna grab.
Are you in Matt's?
Yeah.
Okay, then I'll definitely see you. So much for getting to lean. God, I love that you can add doc.
This place.
I really, I love the doc comments that Lean has. It got them from Rust, which might have gotten them from somewhere else, but they're so nice.
Dot comments.
Here, look. Look at this. The bigger screen is probably more helpful. Doc for documentation.
Uh-huh. One sec, let me get this set up.
Sure. Come here, switch the pizza. Let's come over here. I'm also curious if you're going to show up in the thing's camera.
I hope not. These guys always pick me up.
Looks like no.
Thank God. Alright, setting up clean and sign in on your machine. Oh, that rhymes.
Okay, well, let's just set up lean. Side lean is trivial to install once you have lean. It's just a library. Okay, did you already install lean 4?
Yes. On VS Code.
Okay.
I already opened a project.
Do you have the lean 4 binary? Like if you type lean or lean 4 in the terminal, does anything happen?
Nope.
Here. I sent you something. This is the lean version manager based on Rust up from Rust. It's called Elan because it's E and
Hilarious.
switch.
Yeah, I know.
And because it's a word.
Elan, what does it mean?
Essentially elegance.
Elan.
What is the etymology? Vivacity. From Lansing.
Alright. I'm just gonna do the obvious thing and do the curl thingy.
Yeah. It'll tell you stuff. I recommend using the nightly toolchain. Because it's so actively developed, the nightly is usually just like the most stable, ironically.
Uh-huh. Okay. Wait, why ironically?
Because also it will sometimes just break because it's the nightly. And then
Nightly?
there's like a day of either switching down a version or just waiting, and Rust had this too. But the stable version, despite being like stable, more libraries tend to keep up to date with like the latest version of Lean, or almost the latest version.
Okay.
Like this one, I think is 4.10 release candidate 2 is what MathLib uses, and MathLib is by far the biggest Lean library, probably bigger than the compiler by a good margin. Millions of lines now. Huh. It looks like the second biggest contributor works at Harmonic.
Harmonic? Oh, that place your.
Yeah, but also the one you get. That's quite a bulk of commits. Oh, this is just for this year too. No, 3 years. Line counts have been omitted because there are more than 10,000 commits. Okay, I guess that's a sign the project is big if GitHub won't even just show the full thing because it has too many commits. Oh, that's okay. Did Elon work yet?
Nope.
Try just lean.
Alright, looks good.
All right, doesn't tap completion.
Alright, I'll just
Yeah.
follow the.
Just clone my repo to install stuff. I'll show you how to do it with Lake, which is lean make. It's the
Lake?
package manager.
Okay.
Unlike C or C++, it has a package repository as well. So you can just like install people's code instead of using like a make file or CMake or something.
That's good.
Go to github.com/alloc/lean-int. Great. And then just clone it. And once you're in it, open it in VS Code and just do lake update and then the and sign twice, lake build.
Alright, what did you say after that?
Lake update, lake build.
Within lean in?
Just lake build. It yeah, and lean in.
Like, okay.
Oh, you probably just sourced it but open a new terminal. Add it to your
Yeah.
bash profile.
Oh yeah, you're right. Alright. I'm in ZSH so I don't know if I'd have any.
Well, then just edit your zsharc.
Oh god, I don't even have a bachelor seat.
You probably have a bash profile.
Whatever, I can just create one. I'm just waiting for it.
Okay, well, here, take a look at this in the meanwhile. This is a, not that. That. Oh, right. This is a doc comment. So Lean has, like a lot of things, many ways to do stuff. To comment, single lines are just a double dash. That's from Haskell. For multi-line, that. In a doc comment, one more dash. This is unlike regular comments in that it attaches documentation to stuff. That's why this is erroring, because a namespace cannot, at least yet, be documented directly. But this notation can be. So this helps with custom notation being incredibly confusing normally, because it lets you isolate where the notation was at least declared, instead of it becoming completely implicit in the code and impossible to fix.
Yeah.
Can still be a nightmare, nonetheless. What this is adding is actually array syntax notation.
Make up lake update lake
Build
build.
there. And it gives incentive to write documentation, or at least have GPT write it, because if you hover, your documentation shows up immediately.
Oh, that's good. Well,
Quite
Python,
motivating.
I get that too with various Python extensions.
All right, these will fail now.
Do you remember what extension? I've been trying to find this for ages. Well, not very hard. The extension, VS Code extension that lets you just import stuff if you right click on them.
Auto
Actually, you
import.
know what? I'll just add perplexity.
Yeah, that's
Yeah.
good. Can I document this macro rule?
So convenient.
Oh yeah, I can. All right, I learned this yesterday. Huh. This is interesting. Look at this. If I just hover over this if x, it goes to my own notation. So, but it also highlights the scope of the notation. Like Lean has quite good tooling for
Something that
has barely 2,000 users.
Yeah, no kidding.
Like even where bits of code are broken, the rest of it will work at least as much as possible. Of course, if a function depends on a broken function, that's not going to work.
Yeah.
And so here I just added array comprehension or list comprehension like in Python because I wanted it
Where did you do that?
right here.
Grow rules. Okay.
Like it does it by cases where it's just, well, an empty array is an empty array, so I don't need to give a new interpretation to that. It's saying that given this form,
You should translate it to the other.
yeah, where since x is an array, I can just do dot map, and this is
What does the hashtag do again?
the hashtag is just a symbol marker for array. If you use just the,
Oh, I see.
it's just a list, but that's a linked list, which is a terrible data structure. You could switch them in notation, and as soon as you define notation, you can immediately use it. Like I use it to recursively define itself sometimes, but you shouldn't do that.
Okay.
Because like switching well known, well in the community, well known notation like that for personal preference,
We'll fuck things up.
you can put all of it in a namespace so it won't leak out. It has a lot of things to avoid just polluting the namespace with random notation, but it would just be really confusing to read. Because ultimately, someone has to like look at this, and imagine looking at this without the info view. There's here
The info view.
this thing where it's telling basically everything.
Oh.
Like if you writing a proof, it's what will tell you when you're done. It'll also tell you what you're even trying to prove, probably more precisely than you could imagine.
Okay.
And here I used it to define a Cartesian product with the list comprehension notation. There's some built-in function that will do this easily, but it's nice. This is the whole idea of defining your own language to make problems easier to solve.
This is very neat. Sorry, one sec. Let me finish this up.
The lake build.
This one failed. Nope.
Okay, why did it fail? Let's say it might not be a real failure. Oh, that's fine.
Okay. I can
Because
ignore that.
the only thing that failed to build is in the file that's being edited currently. Yeah, everything else built fine. That's okay.
Wait, I'm in the restroom.
Okay. They're probably not doing talks, so there's one over there. Otherwise, like off to the left next to the wooden onion. What is wrong?
Okay. Should I just follow the linked docs now?
Hang on. I'm just fixing up a bug I just introduced because I didn't know exactly what the word intercalate meant. You know, just a common everyday issue.
Intricalate.
Intercalate. These guys really put some work into the chained completions.
Hmm?
You can edit this. Generalize. I wonder if it will know I meant to generalize it. Yeah, it did. Intercalate. Copy at list. Enter. Will that work? It will look for symbols that will match, which sometimes works, sometimes doesn't. So let's just try this. And then it will edit. It'll like change the changes. But if I reject it, it'll just go back to the previous state. And you can kick off multiple ones in parallel. IDK. I didn't
that's
even use
cool.
the parallel feature that much, but I should.
Parallel?
Like kicking off multiple of these. It's not like they're actually being edited in parallel because I can only type so fast. But I can put different editing instructions in each one and just do it in one instead of getting caught in the weeds.
Mm-hmm.
Just lay down a pass of rewrite this section this way, this way, this way, and I can give very specific instructions for each block. And then I can just like hit generate for all of them at basically the same time.
Mm-hmm.
I didn't even use that feature yet. Okay, first thing with lean is always have the info view open.
How do I do that?
Well, VS Code or cursor, which by the way is a fork of VS Code, so you can port all your extensions. So switching is very easy to try out.
Okay, how do I do info view?
There's a command with like Command Shift P or Control Shift P, whichever one it is. Toggle info view. You have to have your cursor on a lean file. And info view should be one word. Yeah, toggle info view. Which should probably show basically nothing right now.
Nothing.
Yeah. And if you hit control backtick, it will toggle the terminal
Hang on. Control backtick.
with command. They hit it again. There.
Nice. Is this is not VS Code specific, this is Lean specific?
The backtick thing, that's VS Code.
Oh.
The info view is lean specific.
Nice.
Well, mostly.
Oh.
You paste in the
Yeah.
terminal.
Targeted.
And I guess toggle info view if nothing shows up. Oh, it maps it to Command Shift Enter. Okay, there. Now put your cursor on a specific spot. Like actually click it. There. It will show you whatever the local context is, and what that is will depend pretty heavily on that. It can render arbitrary React, which is why someone did the Rubik's Cube at one time.
I'm starting to understand why people like Lean so much. This is actually very... Alright, let me actually read this.
Okay, this is why I think Lean will succeed. This is the side lean guy, and it's not so much if he succeeds in this goal or not, but just look at the things he's talking about. Define semi a mesh as a pre-sheep over this category, yada yada. And then it's like forward inverse mode, mapping the cotangent, etc. That the community is so highly skilled because it's mathematicians. Like even the most incompetent member still has to have some skill, and the verifier can ensure that you can write code and just hand it off to people to implement if you specify the types well enough. That if the verifier says they're done, then somehow the idiot pulled it off.
I see.
As long as you're verifying the things you write down as the properties, it needs to verify are good enough. Which at least for a theorem is like, is the theorem true or not?
This sounds like the perfect language to combine with GPT.
it works well with it. Like the way it does completions here, function by function, because it compile all the functions in little blocks, it lends itself to just like easy running, because it doesn't matter if one piece is broken. That part's like a better Jupyter notebook, but it doesn't have any plotting capability, at least not yet.
Mm-hmm.
It like lacks libraries, sadly. But GPT will make that easier. Intersperse. What if it let me rename it? Holy shit, that seemed to actually work. Yeah, fixing up the broken bits is just as easy as following the compiler. There. It's not intercalate, but intersperse. I find it funny that this would probably be considered bad lean style, calling it array instead of like ARR or X's or something shorter,
Mm-hmm.
or even leaving it unnamed and making this like a partially applied function. But actually just using something absolutely unambiguous like the word array would be controversial. It's like you can infer from the type.
That's not good.
It just I think the more I program, like the less I care about really short names and clever code, or at least I'm less enamored of it than I once was.
Yeah, I'm also very much in favor of variables should be long and understandable. Something anyone could just pick up and read.
This is interesting. If you have a hypothesis, this is some of Lean's syntax. When you're doing a for loop, well, it'll actually tell you what H is actually. H has the type of a proposition that I is in the collection call, which is a range that this is from 0 to the size of the array.
It's of type it proposition, it's in blah blah blah.
Yes.
Bruh.
This is the difference between like booleans and propositions. The like booleans are just like values that are named to true and false, and you can just return either of them. But in a proposition, you can't like return a false proposition because the proposition is defined as like a proof that it's true by constructing some function that demonstrates this. But if it's false, well, no such thing would be possible. In fact, the way that things are proved false constructively is by showing they derive a contradiction. This one uses classical logic. It includes the axiom of the excluded middle. Well, actually, it includes the axiom of choice, which implies excluded middle.
What's excluded middle?
That any proposition is either true or false, but not neither.
Oh, I see.
It could be some indeterminate one that's just impossible to judge.
Yeah.
One of my favorite definitions of the boundary of an object from Lauver is x and not x, which has to be interpreted non-classically to not be trivial, but it makes sense because like it's the boundary, so it's part of x because it's the boundary of x, but it's also part of not x, the complement, because it's the common boundary, which is not kind of slick.
Hmm.
This definition is not like computationally useful as far as I can tell, but I like it. And right here, this like colon syntax in the for loop is inserting hypotheses. You can do something similar with ifs in case you need the hypothesis. Here I pull it out because I need a proof that this array is in bounds, and for some reason it doesn't just like figure this one out itself. I should, since the oops, but since the variable name is unused, I should an underscore there. And now my function provably is in bounds. And I got to get rid of the practical thing, which is what I wrote a few days ago because I didn't know about this and I couldn't be bothered to find a proof that it was in there. So I just wrote an exclamation mark and went about my day writing, I think that actually. But now I can go back and fix it.
Okay.
And I just did. So yeah, now this array is it for sure works with the correct array.
Okay.
This is some custom notation.
Oh, should I skip or can I keep reading?
If you see notation that looks like that, well, you're gonna get your math skills worked out because if nothing else, you're gonna be reading a lot of notation. And like the usefulness of that is, well, do you understand the notation? I would recommend starting with this functional programming in Lean. You can even see it in if you, there's a VS Code command, I think like called open doc view. Let's see. Yeah, see, Lean 4, show documentation, resources, and show manual. There, I just clicked oh, this is the manual includes setting it up. Yeah. The doc resources includes functional programming in Lean, theorem proving in Lean, and meta programming in Lean, and a couple of others. Although it certainly doesn't have as much docs as people would want. Also, for 2,000 people, not too bad. I'm comparing it mostly to Haskell in this regard, which for a language that's had much longer did not have nearly such interest. But I think Lean, because of the prover, has a better niche. For Haskell, ultimately still a programming language, even if it's allegedly better.
But everyone who wants to do,
But they can do like in Python.
yeah.
Like saying you can do this in Python is only technically true. And like no one would really buy that seriously.
Yeah.
Whereas like people can buy that, yeah, you can do what you can do in Haskell and Python because at the end of the day you write some functions and stuff. But a prover is very different because it's integrated with the compiler. And no one's thinking Python's going to do that. Actually, this guy used to be the head of the Haskell Foundation and then he left it for Lean recently-ish. Yeah, see, and he was the executive director of the Haskell Foundation. I first have heard about him from his book, The Little Typer. Do you have to go to SF now?
In a bit,
Okay.
probably in like half an hour.
All right.
How far would it
San Francisco. Probably at least half an hour drive. Oh, it's next to 16th Mission.
That guy there in the black shirt, that's where they all are. He just walked into the kitchen.
That's where my other office is.
Oh, they might be in the same. Well,
Wait, 1680 Mission?
um, no. Oh, wait, that's a different. Whatever. Not really important.
Do you also get your text messages sent to your computer? Yeah,
Well, some of them is the problem, not all of them.
that's fixable.
How?
I think you set it up on your phone's end that it would forward it.
Okay.
Also hit like Command comma to go to preferences here. You should set that up later, by the way.
Mine?
Yeah, or at least put your name.
Mm.
No. Okay, it looks like. Yeah, I think you need your phone for this half.
Okay. Don't care enough
Yeah.
to figure it
The
out.
phone settings in messages, there's a thing for where it forwards stuff.
Oh. Um,
Was it the way he said, "Hey, Aaron"? Okay, the lean extension's been installed about 40,000 times. Yeah, most important thing in lean is just type the expressions directly and use eval a lot. If you run the script from the command line, which you can do, although it's usually people just do in the editor directly by its interactive nature, but it can just as well run as like a real script.
like that.
I can't actually see your screen from this angle. Yeah, just like that. And then, well, you should have the info view, like maybe hide the terminal or something, because otherwise you're not going to see your fruits. Yeah, and when in doubt, hover your cursor, click on stuff, and you'll get the types.
Oh gosh. It just. Huh. That's cool.
It's just a what?
Just gives me the answer if I hover over.
Yeah. And yeah, use go to def a lot.
Go to dev. What's that?
Definition.
Ah.
There's the whole jump list of like going forward and back. I don't remember what the original command is because I remapped it, but I use control right arrow to go to definition, then control minus to go back.
Mm.
Lean has a few commands besides eval, like reduce, check. Check is probably the main one you would use otherwise. It does type checking and also synth to see if there's a type class instance or something. You probably don't need to worry about that one yet.
All right.
All the white space syntax might be familiar from the shell script.
Shell script, no.
Well, if you think about it, like the RM command and then arguments after. RM is the function, F, and then all the others are X, Y, Z,
Oh, sure.
separated by spaces. It's just that in Bash it's kind of shitty, and so it can take an arbitrary number of arguments always and eats up the whole command line.
Yeah.
Maybe it's like we build our own separate policy. This example always on there, like something, oh, I hate walls, I hate, stuff. They always have. It sounds like, see, that's true. Like, there's a certain discourse, like policy spaces, that works. So, always very opposed to. That's easier. Hollywood. Pragmatic. It's like a probably special steps.
Hmm.
No parentheses. In fact, you said rather than writing. The
Oh, I skipped that part.
the way that it would interpret that, I think, is actually as if there was a space, and then it would be one argument, which is a tuple of strings rather than two strings.
Mm-hmm.
I didn't make it happen. It just happened to you, like Adam Berkeley. I
Yeah, I don't like this because it interprets them as natural numbers. To make subtraction a total operation, it just floors them to zero, which is cursed. I think it's because mathematically there's such a strong pressure to have every pair of inputs defined. But here, because it tries to define the subtraction as returning a nat, but it really should return an int. But sometimes it would be a nat like 6 minus 4.
That is quite bad.
And to type all the Unicode characters, if you hit backslash and something, it'll tell you. Also, if you hover over the Unicode characters, it usually tells you how to type them.
Where?
Uh,
Wait, give an example.
Sure, from the notation I defined just yesterday. Where'd you go? The other hash map notation. Oh, right here.
Oh, that's cool.
Yeah, this one at backslash T.
Hmm. That's slightly cursed.
What? The subtraction thing?
Yes, I would have expected order of operations for it to do this and then cast it to integer, so it should still be 0, but it figures out that it should be an integer and then does the operation.
Yeah, the type apps ascription is supposed to give everything on the left-hand side up to parens a type, and then it will call a
so
different
it-
subtraction function altogether.
Wait, it casts 1 and it casts 2. Okay, I see.
No, it's not doing that at all. What it's actually doing, I think, is that it... I don't think it will actually cast them in this case. It will call the appropriate subtraction function that will return integers. That might internally cast them for all I know.
That is very cursed. I would not be able to predict how this works on like arbitrary.
Well, yeah, because the subtraction function in most of these operators are overloaded. And the way to define their behavior is that, like, the equivalent of, well, okay, C++ has equivalents, although ugly ones, and C has no equivalent at all to this, because C doesn't even have generic types.
So 1 and 2 are still natural numbers, but it's subtracting them
Yeah,
with
like-
different operation.
Sub,
Fine.
nat, int.
I can certify that.
Write this line out, see if something shows up. For some reason, maybe if I restart it. Something like with my latent instance. And what it's saying, well, you'll see. You can go to def or hover over them, and it should tell you what h sub and all the others do. Try, make all 3 ints. Wait. I'm actually going to make sure that what I'm saying is right by taking that example and adding some parens more carefully. Oh, fine. Okay. So interpreting 1 and 2 as nats, and then interpreting the whole expression as an int works. This would probably also work. Oh, thank God. There. This is what synth did for me. Not that part. This isn't, you can tell from this kind of shitty name that it's an auto-generated function name. And if you click or right click, which takes you right here, This extern means that it's actually not done by this, although it's logically equivalent to whatever this is. But the real implementation is using something under the hood for speed, which is good.
Okay.
This is how lean can be fast. Because if you didn't have this, it would be unusably slow. The at signs and stuff, I think these indicate pointers and are custom notation. There's custom notation for everything.
Wait, what indicates pointers? The ads?
I think so.
Ampersands?
Yeah, I forgot what they correspond to. But anyway, it's just to find subtraction by pattern matching. This is another good example of a type class. If any type that you can write this hash function for that behaves as expected is hashable
Okay.
and can be used in any context where some hashable type is expected. And chaining these together is the main means of achieving abstraction. It goes well with the mathematical mindset because, for example, like the idea of subtraction as a type class that takes two things and returns a third thing. The H stands for heterogeneous, and there it takes possibly separate types for both of the inputs and the output. And since it's dependent, the output type can depend on the input types. But already you have at least three types that can be invoked, whereas just sub is the homogeneous version where all three types are the same. But it is a special case of H sub. All this like special casing and slotting things in is very much in line with type classes, and mathematicians like it because it's just like putting the pieces together. The first Turing Award winner, Alan Perlis, he was known for just like getting it more than for his technical work, like what computer science was all about. And one thing he says that it'll turn a clerk into a mathematician and a mathematician into a clerk, and that's so true because I've seen so many people in math lab just like organizing lemmas and stuff. Oh, actually, speaking of organization, one restriction of lean and most theorem provers that C might have, I don't remember. Everything has to be defined before it's used.
In
In lean.
lean?
Yeah. This might not seem like a real restriction to you, but in some languages, you can define the functions in any order.
Yeah. Well, as long as you declare them in C, you can use them whenever. Okay.
Okay. This one doesn't have the forward declaration thing. It
Oh,
can
that's
have
okay.
mutual. It doesn't need it. If you need mutual induction as well, you just have like a mutual block. This is taken from OCaml. So you can define multiple data types that recursively depend on each other. The classic example is just an even and odd data type.
So it doesn't require what was I gonna say? You can do this with multiple, not just two things that depend on each other. You can
Yeah,
have
yeah.
everything. Okay.
You can have as many as you want.
Oh, that's convenient. That's the one thing I fucking hate about Python. It's really annoying to have like circular imports.
You can't have circular imports here.
Oh, that's unfortunate.
I don't know any language that really allows circular imports fully.
You can get around it in Python with like some stupid shenanigans, but it's really annoying.
And in C, you get around it by not having imports because you don't use other people's code, which is awful. Oh,
One sec, I need to
Yeah.
email my stupid workplace. Sorry.
I wonder if this is a tokenization issue with cursor, where often it will keep trying to suggest replacing that with an empty string and then all these with just spaces, even though that's definitely wrong
Yeah.
and would make not even valid syntax.
Weird.
See, already it's like suggesting getting rid of it. Literally just one curve. I don't know why it's like so hell bent on it for just this one notation.
Mm.
There again. Trying to replace it with at least one space. Very weird. This is me putting my hashback notation into action and then later using it to define that polynomial notation from yesterday. These are various casts that you can just turn a natural number directly into it. Because in Lean, the numerals are actually polymorphic. Like even the literal symbol 0, it doesn't necessarily mean anything yet. It's anything of the type class of nat of 0. It gives it a default type of nat because writing like eval 0 and getting an error would be very annoying.
Yeah.
But if I do it 0 as type of, oh, it's right there actually. It gives the empty polynomial, which is 0. Because, and then I can also cast any number, any natural number, and then anything written in floating point or scientific notation as well. Because they're just a polynomial of with only a constant term. And in the case of the Levi Civita field, there's just a term where I fill in the finite term, but the infinite and infinitesimals are 0.
I don't know the Levi Civita form.
Field. Levi, so there's the hyperreals, which have infinitely big and small numbers. Problem is that constructing them fully is like on a computer is impossible. But it's not too bad. There's a smaller thing called the Levi Civita field. Levi Civita, Tullio Levi Civita was an Italian mathematician from like 100 years ago. Einstein collaborated with him on his work too. Tensor calculus came a lot from him. And this field, however, is not tensory. It looks like this. I guess I've given a more precise definition of it in code, but this is the ideal thing. Non-Archimedean, Archimedean is just for Archimedes, and it's the Archimedean axiom, which is just like given two numbers, you can find a third number that lets you multiply one to exceed the other. This is not true of like infinitesimals. There's no standard number you can multiply an infinitesimal by that'll make it bigger than any standard non-zero number. You can multiply by an infinite number, but that's like on a different scale. So this axiom, Non-Archimedean really just means like numbers can exist on different scales, which is good because the Archimedean property, if one, it's an axiom, and two, I think this axiom is just false. And three,
Axioms can't be true or whatever.
insofar as they correspond to anything
Oh, sure, okay.
real or the actual world would have some non-Archimedean nature to it.
As in, you can find an object.
Well,
that
you might not be
satisfies
able to find it, what with the whole nature being infinitesimal and infinitely small. Nonetheless, though. And math has gotten much farther with the non-Archimedean one, since it includes the Archimedean one as like a special case.
it. Okay.
Because it's just like the Archimedean one is like you have only standard numbers. Here you have those, but you have like more. Just think of like natural numbers, but now you have negatives. Imagine like fighting with someone over like the value of negative numbers. Let me see how math works or a new method. This is so true. My God, I wonder if this is true. Impossible, insane. It's not just incorrect, it's an entirely new category of stupid. All of them have mustaches or beards for some reason. Debate. It looks right, but it can't be right. Perhaps you could restructure. You think this is a joke, but for how people have reacted to non-standard analysis, this part just cuts true. There's also people who have restructured all of math in a way that makes it right, but that turned out to be easier to do because it works. You say xi psi of del squared, the Laplacian of z is equal to the second derivative of a bracket of something. I say your mom's a whore. And now he's bald. One day that will come. And that's like this for negative numbers, zero, imaginary numbers. People think mathematicians are extra eager to embrace them. I don't think so. I think that they're earlier to them by nature of discovering them, but they tend to resist them just as much as most people for a long time. Like zero was invented roughly the year 400 and was resisted quite vigorously in the West for say about up to 1,000 years after. Negative numbers and complex numbers became accepted. I mean, they're called imaginary numbers because René Descartes came up with Cartesian geometry and the whole Cartesian grid, thought it was some bullshit. They weren't exactly embraced because Cardano said dismissing mental tortures. He computed, I think, what was it, 25 times 15, 25 plus 15i. He computed its conjugate, which is, I think, 40, which he said was as subtle as it is useless. Nevertheless, we will operate. And he went on to do it. If it isn't for the fact that there are real equations, like cubics, with three all real answers, that if you want to use the cubic formula to work it out from principles, you have to use complex numbers, I think is the only reason people really like stuck with it. Because like to get like real answers, they needed this and they couldn't find a way around it. And no wonder because Galois theory later showed that it's impossible. Like there are real equations that to solve them, you will necessarily have to introduce I at some point, but at the end they're guaranteed to cancel out.
Oh, really?
Yeah, but you can't escape it.
I see.
And if it wasn't for that stricture, we might still just say it's some bullshit and then imagine we basically like monkeys playing with shit on our hands. Nothing. Anyway, Levi Civita field is smaller where because the hyperreals contains all sorts of crazy stuff like infinity, some infinite number h to the power of pi minus 4.2 times h is 1 over epsilon, where epsilon is like a unit infinitesimal, or rather h is a unit infinite number,
Okay.
a hyper integer or hypernatural. I usually like to make it a unlimited prime number, an infinitely big prime, so no finite number can divide it and no infinite number less than it can divide it either. Such numbers are guaranteed to exist because of the transfer principle of non-standard analysis, that this is a first order formula because it quantifies over elements. For every element of the naturals, there's some prime number bigger than it, which is true. Therefore, this formula is true in the hyperreals, which means for every hypernatural, there's some prime bigger than it, which means there have to be infinite primes, because obviously a finite number can't be bigger than an infinite one, which is wild.
Sure.
The thing about functors in philosophy, it doesn't matter if you actually buy that infinitesimals do or don't exist because of things like this principle that justifies using them.
Fair.
But you're a mathematician, or sort of. Since when did you care about philosophy?
True.
Here, you just end up constructing a power series where the terms that are infinitesimal can go forever, like a Taylor series, but the terms where this is negative, and so this would actually be h, the infinite terms, you have to have a finite number of them. Of course, for a computer, you have to have a finite number of everything.
Mm-hmm.
And so I've been defining this as a data type, or at least an approximation of it, as a hash map from rational numbers to their coefficients, because the epsilon is implicit.
Mm-hmm.
And then because it's a disjoint union. And then I define like addition and multiplication. I did subtraction. I need to do ordering and I need to do division. Division is the hardest one. Because for one, you basically use the geometric series, and some guy sent me a thing about this, and that requires more thought. But also just that the inverse of some infinite, that was when I said that 1 over x is like a conservation of difficulty, that there's this dual, like even in this definition, where the infinite terms, there can only be finitely many, but the infinitesimal terms, there can be as many as you like.
Mm-hmm.
But as soon as you allow reciprocals, then, well, 1 over an infinitesimal is infinite. And so 1 over 1 minus epsilon, well, that one's inverse would just be 1 plus epsilon squared, and so on. But you could have some where you would have a bunch of h's too.
Infinitely many.
I don't know if you can have infinitely many because of this restriction that this be finite. But ain't it a bitch? And yeah, the real numbers are embedded in this field. It's just like constant terms.
No, if you take the reciprocal, like, okay, maybe I'm misunderstanding what you said. If you take the reciprocal over 1 minus h, you're gonna get infinitely many h's, right?
Oh yeah, 1 over 1 minus h, 1 plus h squared.
Yeah.
Because they're all getting bigger.
Yeah.
And the best you can do for that one is to just like cut it off.
Okay.
At some point, I want to learn how renormalization works, because I suspect this whole thing of cutting off of infinite numbers will benefit from the light of non-standard analysis, because it at least gives some rigor to the idea of an infinite number in the first place. And it's a more useful notion than cardinals and ordinals, because ordinals you can add and multiply them, but addition of ordinals is not even, oh, and of cardinals too, but cardinal addition is not even commutative. I think ordinal is though. And but you can't divide or subtract or take a square root or remove 4.7 from them. That's,
Yeah. Well,
but these you can.
Okay.
It doesn't mean you can like actually figure out what it was, but as far as expressions go, it's just as meaningful to take the 4.7 power of some infinite number as it is to add 2 and 2. It's just not nearly as easy to compute.
Okay.
And I think approaches like this, where you can just like have everything work better, rather than figuring out what you are or aren't allowed to do, you just like do stuff, and you just rely on the field you're working in to be big enough that the objects you need to exist do exist.
My father always said you should start with the objects, not with the axioms. And
Well, this is a good object. For a guy who hates analysis, he's like most people, he doesn't care about non-standard analysis either, because it's quite esoteric, even among mathematicians, which means it's really esoteric.
he doesn't hate analysis.
Yeah, but he hates inequalities. He doesn't like proving A equals B by doing A is greater than or equal to B and B is greater than or equal to A to squeeze them.
He's never mentioned that to me.
He's ranted about this in a lecture a few times.
Oh, I see. It's a great trick, though.
Yeah, but there's a better trick with this, which is just say they're infinitely close to each other and then use the fact that if two things are standard but are infinitely close, they have to be the same.
Mm-hmm.
And that being infinitely close is an equivalence relation. The equivalence relation gives you transitivity, which is what you really want. Because even with like the greater thans, you end up chaining together a bunch of inequalities. to squeeze something maybe through like several layers of this telescope of quantities. But here you can just say A is infinitely close as to B is to C is to D. And as long as the chain is finite in the end, then first thing's infinitely close to last thing.
Yeah.
This is also why you can't extend equivalence relations in general to infinite things. Because like this is basically saying something is next to or is near something. And for any finite amount, that's true. But once you have infinite, that's like saying everything is near to everything, which is false. Or at least trivial. You can get automatic differentiation by just doing ordinary arithmetic on them. If you want to do second and third derivatives, you just carry around the epsilon plus epsilon squared terms, plus epsilon cubed for third derivatives.
Okay. Interesting.
And then like the math of Taylor polynomials will just work out. Like dual numbers, auto div possible. Sure. I want to see if Lean can one-shot this. That if it can just do the whole thing. If it can't, I'll just show you, but I want to know. There. While it's going. Ugh, that's messy. It's saying that some dual number of type A, just fill in floats for now, is actually a pair of floats, one of which represents like the normal term, like A or X. The other term is the infinitesimal one, though, which is basically dx. And then if it uses an axiom, said in this ugly way, that dx squared is 0. Although dx is not 0 itself, but it squares to 0.
Okay.
The hyperreals do not have this. In the hyperreals, it's definitely not 0. Dividing by 0 is still illegal, although you can divide by numbers infinitely close to it, which is usually good enough, thankfully. And there's nothing, the only thing that squares to 0 is 0 itself, but you get most of the benefits. This is essentially like cutting off the Taylor series at 2 terms. They could have had some axiom that like the fourth power is 0 instead, just that it's nilpotent. Yeah, as an analog of the complex numbers, but I squares to 0 instead of 1. You can get the hyperbolic numbers by making it square to positive 1, and the complex numbers by squaring to negative 1. I think these are also called the parabolic numbers sometimes. Hyperbolic because negative term, like negative curvature, like hyperbola. Parabolic because like flat or 0. And elliptic or spherical, or in this case, dot, dot, dot. Did I get the... Yeah, negative curvature would be hyperbolic. So yeah, you say they're equal if their parts are equal. That's trivial. More interesting. Here, this is more interesting. That if you add them, well, you'll see that like all the dx terms go to their own side, and all the not dx terms go to their own side, and that if so, this is b dx plus d, I don't know, y. These are all infinitesimal, but they're not the same infinitesimal.
Okay.
Because this infinitesimal was attached to this A and this was attached to C, and although they're the same type, they aren't necessarily the same value, but they are both infinitesimal.
Infinitesimals attached to A and C, but not D or B.
B or D is infinitesimal.
Okay, okay. Wait, what's the D then?
The big D stands for just dual, but it's also supposed to mean...
Oh, okay, okay, okay. I see.
So the sum of two dual numbers is summing them component-wise.
Sure.
Negating is what it looks like, yada yada. More interesting is multiplication. That gives you the product rule, and from that you can get the idea.
Oh, fuck, I gotta go.
Okay. Oh, it's right there. Okay. Well, if you look at this, you'll see that this is the product rule. This is like C A plus dx times C plus dy should be A times dy, which it is, A dy plus B or b as dx times c, which is true. This is ugly, but this is the product rule. Using better notation, this would be more clear.
Okay.
But then from this, just overloading these few operations, you just replace the floats with dual floats, and then they will come with their own derivatives for free. This is not the most efficient way to calculate it, but there's all these compiler things that will make it better, and this is a somewhat underexplored area. And part of my interest in Levi Civita field is it seems to be like the most generic thing that allows autodiff, including a functions that are discontinuous.
Oh, that's your project.
With this